Hello, ladies and gentlemen. Welcome back to math class. I hope you had a wonderful weekend. I had a pretty good one. So on Friday, we talked about absolute value functions, right? These aren't notes, this is review. Absolute value functions, which means that no matter what x value we put in, it's going to end up making it positive. And so what we ended up was with a shape that looked like this. Because no matter what our x value was, it was going to have to be above the x-axis, because -5, right? If I was supposed to go down 5, well, if it's made positive, then I have to go up 5 instead. So my 5s would be here. So that was kind of what we talked about on Friday. We're on our, looking at my calendar, last graphing function. Woohoo! If you don't like graphing, yay! If you do like graphing, aw. But either way, we are on our last one that we're going to cover, and it's called a rational function. And rational functions are my personal least favorite, but there's nothing wrong with them, and they didn't deserve it. They didn't do anything. And a rational function, for our purposes, is going to look like this. Sometimes it might look like this. But most of the time it's going to look like that. And I will make sure to completely explain this. And actually, we're doing a lot less with the rational functions that we've done from all the other ones. And we won't be using a t-table. What? But first, to talk about rational functions, we're going to have to define some terms. The main important one being this, an asymptote. Have you ever seen the word asymptote? You're not here to answer me, and that makes me very sad. But an asymptote basically means an invisible line that a curve is approaching. Okay? Let's say, I like that definition actually, I'm not going to change it. An invisible line that a curve is approaching, getting closer and closer and closer to. Let me give you some examples. Let's say you have a line here, and you have a little curve going like that. Do you see how it's slowly getting closer and closer to the line? That line is an asymptote. Let's say you had a curve like, let's do a crazy one. Let's say you had something that was like this. Where it's getting closer and closer and closer and closer as you go further. That line's an asymptote. Now let's say you had your normal coordinate plane and you had a line that was doing like that. Well, guess what? Your x-axis is an asymptote, and so is your y-axis, because this little arrow is getting closer and closer to that x-axis, and this little arrow is getting closer and closer to the y-axis. And hint, hint, this might be a preview of what we're going to be seeing. But an asymptote is an invisible line that a curve is slowly approaching. And for a rational function, that's going to be a line that it never crosses. And I'll show you exactly why in a second. So, you're not going to have to fill out a t-table, but I am, because I need to show you what happens, because it's really crazy what happens with t-tables for these problems. So let's take 1 over x, right? I'm going to make my t-table, and please copy this for your notes. You won't be having to draw them yourself, though, because they're weird. And I'd rather teach you this in person than online. So, 1 over x. I don't know, let's start with 0, just for kicks. What happens if I plug in 0 for x? What is 1 divided by 0? It doesn't exist. So we don't have any dots, any points crossing that. There's nothing crossing that. Okay, well, what happens if we go to maybe, I don't know, -2? What if we do 1 over -2? Well, we kind of get -1/2. Okay, what happens if we go -10? Okay, well, -10, we end up with -1/10. Okay, Well, that's crazy. It looks like the numbers are just getting smaller and smaller as I go. Smaller and smaller fractions. Okay? Well, let's try something else. Let's say I plugged in a half. What happens if I plug in 1/2? 1 over 1/2. Well, to solve this, you have to flip the 1/2, so you end up having 1 times 2, and that gives me 2. Okay, what if I do 1 over 10? What if I plug in 1/10 for my x? 1 divided by 1/10? Well, I flip the 1/10, so I end up with 1 times 10, that gives me 10. Okay, what the heck is happening on this t-table? So rational functions are weird in that the closer, let's say, for this graph, the closer your x is to 0, the higher, positive or negative, your y. The further your x is from 0, the lower, positive or negative, your y. What I mean by this, and if you need to pause to write this before you listen, please do so. Negative one or negative. I'm sorry. Let me reboot. What's closer to 0, 1/2 or -2? 1/2 is definitely closer. And look what happened. My y value is positive 2, which is further away from 0. If I plugged in a -2, then I got a -1/2. So plugging in a fraction that's closer to 0 gives me a bigger number. Plugging in a number that's bigger than 0 gives me a fraction. And when I graph this, it doesn't help much for sense. It gets really weird. So watch this. I need to have 10 available. Okay, so that'll do. So let's graph these points. So if I try to graph 0, I can't. There's nothing in the middle for me to graph. If I go over 1/2 and then up 2, I have a dot right there. If I go over 1/10, so a tiny bit, I'm already up to 10. Wow, that's weird. So it looks like I have this really slow sloping line here. What happens if I go to -2, -1/2? Left 2, up -1/2. I'm sorry, left 2, down -1/2, okay? What about -10? Down -1/10. So I go all the way down to 10, and then go only down 1/10? Okay, this is confusing. How am I supposed to graph this? Well, that's why I'm not going to make you guys do it. Let me explain what's going on here. So what happens if I plugged in positive 10? Then I'd end up with 1/10, right? So if I go over 10 and then up 1/10, I got a dot right there. What happens if I plug in 1? 1 over 1. I get 1, 1. Okay, this is more of a shape. What happens if I plug in -1? I get -1. What happens if I plug in -1/10? I get -10. So what you have here is a crazy shape that looks like this. These didn't touch, but just pretend they did. My drawing is bad. You have two curves, one going from here to here, the other one going from here to here. And guess what? They're never going to touch this y-axis, and they're never going to touch this x-axis. Why? Because these are asymptotes, okay? Don't worry. I know this is overwhelming right now, but just bear with me. So, I'm not going to make you graph this. What I am going to make you do is figure out what the asymptotes are. So, my equation is 1 over x. The question of the day, okay? The big ol' question of the day is, where can x not equal 0? This question gives you one certain number. this tells you where your vertical asymptote is. If you can answer this question, then you found your vertical asymptote. So let's ask the question. Where can x not equal 0 here? What would x have to be to make that impossible a fraction to solve? We already talked about it. X can't equal 0. So if x can't be 0, then my vertical asymptote, and I'm going to trace this with a purple marker, if my asymptote is at 0, then I have an invisible line stretching from here all the way up forever. And these curves are not allowed to touch that asymptote, ever. They're not allowed to touch that. Now, I'll show you how to find a horizontal asymptote after this short little break, where I'm going to show you a cool website. Hello, ladies and gentlemen. Welcome to desmos.com, DESMOS.com. I'd really recommend you playing around with this website for a second while I have it open, just to tool around with the rational expressions, because not all of you guys have graphing calculators, and it's super important to be able to see it. And I think it's too hard to graph by hand. We could, but it's just annoying, and I don't want to do that without you guys in class with me in person. So we're just going to use the internet for now. So this website basically lets you graph stuff online, which is pretty fantastic. I lost my mouse there. I'm using a dual monitor setup. So watch this. If I just type in x, there's a whole hotbar down here. If I just type in x, that gives me a line, right? Because the graph of x is a line. What if I do x squared? Parabola, because x squared is a parabola. X cubed, there's a squiggle squaggle, and as you guys can see, basically this lets you graph stuff. Big deal, right? So let's talk about rational functions. We talked about asymptotes, and that a rational function basically means it's a fraction with x in the denominator. So look at this crazy shape we're getting. Look at that. Isn't that weird? Why is it making that shape? And why is it too hard to graph by hand? So let's think about this. So if I have 1 over x and I plug in 1 for x, 1 divided by 1, what does that give me? 1. So if I plug in 1, so over 1, I'm going to go up 1. Up 1. There's the point 1, 1. Fantastic. It's hard to pinpoint. What happens if I plug in 2? If I go over 2, well, now I have 1/2. So if I go over 2, I only go up 1/2. What if I plugged in 10? If I go over 10, that's 1 over 10. I'm only going up 1/10. What if I plugged in 20? If I plugged in 20, I'm going over 20 and then up only 1/20th. See, the bigger the number you plug in, the closer to the x-axis you're going to get. And the crazy thing is, if you go super far out, let's go to 2000. If you go super far out, watch this. Never touches. No matter how far out, it's never going to touch. Oh, I'm not close. I got to get further out. Oh my gosh, my numbers are too big. Okay. Now what if x is 1/2? Let's go the other way. So instead of going right, let's go left. What if x is 1/2? 1 divided by 1/2. Well, typing that in your calculator, you're going to see it's 2. So if I go over 1/2, that means I go up 2. What if I plug in 1/10? Well, if I plug in 1/10 and I only go over 1/10, that means I'm going up 10. In other words, the smaller the number you get, the smaller the x value, the higher up your y value is. And the bigger your x value is, the further that way you're going, the smaller your y value is. It's got this interesting reverse psychology thing going on. And so let's think about asymptotes, right? What can x never equal here? X can never equal 0, because 1 divided by 0, look what this does. It does nothing, because you can't graph x equals 0, because that's undefined, that doesn't exist. So x can be 1. We just showed that. X can be -1. 1 divided by -1 is fine. X can't equal 0. So if you'll notice, if we go really far down where x equals 0, let's go really far down again to like, I don't know, -17,000, and then zoom in. Has it touched the x equals 0 yet? It looks, oh, nope, check that out. Still has not touched it because it can't, and it never will. You can go to some pretty crazy high numbers, and you will never actually hit the y-axis, which is interesting. What happens if I put x plus 2 down here? Oh, x plus 2. Hey, look, we ended up with a horizontal shift left 2. Interesting. So what this does, this shifts our asymptote, okay? And this is the main important thing here. Your asymptote is not always 0. Your asymptote means where x can't equal 0. What would x have to be for this denominator to be 0? What plus 2 gives you 0? Negative 2 plus 0, 2. So look, when x is negative 2, let's find that line. When x is negative 2, guess what? This graph is never going to touch negative 2 because it can't. What if I do x, I don't know, x minus 8? Check this out. My asymptote is now positive 8 because what minus 8 gives me 0? 8 minus 8 gives me 0. So the important piece of this is going to be for you, can I identify an asymptote on a graph? And that's what I'm going to need you to be able to do. Can you identify an asymptote on a graph and tell me where x cannot equal 0? That's going to be the most important part of this lesson. So we understand vertical asymptotes now. The denominator can't equal 0, and wherever the denominator can't equal 0, you will have an invisible line keeping those shapes from touching it. They'll never touch that vertical line. But if you'll notice, they never touch the horizontal line either. So what's causing that asymptote? And the last thing I want you to be able to do, not to graph these, but is to figure out what that horizontal asymptote will be. I'll show it to you graphically, and then I'll show it to you with math. So the way to find this is your horizontal asymptote is going to be when you have an x in the numerator and an x in the denominator. Okay, so let's say we had x over x. The coefficient for both of these is 1. So 1 divided by 1, the answer to that problem tells you what your horizontal asymptote will be. And look at this. It's at 1. So now what if we had like 1 over x, or 1x over 1x minus 3? This made it look really weird, but guess what the horizontal asymptote is still? It still is going to get closer and closer to 1 and never actually hit 1. Because the coefficient of both x's is 1, and 1 divided by 1 gives me 1. Now what if I do 4x over 1x minus 3? Well, check this out. What's the horizontal asymptote now? Now let's do 5. What's the horizontal asymptote now? It's 5. Because guess what? 5 over 1 gives me 5, and the horizontal asymptote is 5. What if I do 4 over 2? 4x over 2x minus 3. What would the horizontal asymptote be then? 4 divided by 2 gives me 2. So my horizontal asymptote is 2. So to find your vertical asymptote, you're looking for what makes my denominator 0? Right? So in other words, if I have 1 over x minus 5, what value would make my denominator 0? If I have positive 5 minus 5, that gives me 0. So x cannot equal 5, which means my vertical asymptote is 5. What if I had x over x plus 1 over x plus 3? Well, what plus 3 gives me 0? Negative 3. So my vertical asymptote would be at x cannot equal negative 3. I forgot my negative. That's a vertical asymptote. So what's a horizontal asymptote? These are a little more annoying to find, but it's a pattern that should be pretty easy for you to follow, okay? Horizontal asymptotes are found this way. Using different colors because it's a fun kind of day. Horizontal asymptotes are found like this. divide the coefficients of your x's for the horizontal asymptote. Divide the coefficients of your x's for the horizontal asymptote. What the heck am I talking about? This is what I'm talking about. If you have 2x over x minus 3, okay? What is the coefficient of your x down here? Well, it's kind of secretly 1, isn't it? So to find my horizontal asymptote, here's what I'm going to do. I'm going to take my coefficient of x in the top and my coefficient of x in the bottom and put those in a fraction together. What's 2 over 1? 2. 2 is my horizontal asymptote. Okay? What if I have what we started with? 1 over x. Well, what's my coefficient of x in the numerator? I don't have an x in the numerator, so what's my coefficient? It's going to be 0. What's my coefficient in the denominator? It's 1. 0 over 1, how many do I have? 0. My horizontal asymptote is 0. What if I have 10x over 2x plus 2? What's my horizontal asymptote? Well, I'll take my coefficient up here and my coefficient down here. What's 10 divided by 2? 5. 5 is my horizontal asymptote. This is how you find it, okay? The horizontal asymptote is weird, but you can still find it. Now let's see how this matches up with our graph on the first page. Okay, pause it if you need to finish writing this. Okay, so on the first page, which I have upside down, we didn't know our horizontal asymptote yet. So I told you that for 1 over x, there is no x up here, so your coefficient will be 0. There is a 1 understood here. So that's 1. Your horizontal asymptote equals 0. Is this true? Well, if you look, this arrow is never going to touch the x-axis. It's never going to be 0. Which means that yes, the horizontal asymptote is at 0. So, here are your homework problems, 1 through 5. Just find the horizontal and vertical asymptotes. No graphing tonight. Announcements, Wednesday, you will be having a take-home quiz based on all of the graphing we've done so far. Linear, quadratic, cubic, square root, absolute value, and now rational. So that'll be Wednesday. And on tomorrow, I'll be doing a review on common logs so that at the end of the week, Thursday and Friday, we can talk about natural logs. So, with that being said, congratulations on suffering through graphing stuff. Please do this homework. I will have a homework review out tomorrow for these problems. And if you have any graphing that you need help with, linear, quadratic, cubic, square root, absolute value, these, please let me know over GroupMe or phone, and we can schedule 30 minutes to jump on Zoom together and work these out together. But with that being said, hope you guys have a great day, and good luck. Bye.